Postulates number 2. This is page number 82 of class 9 NCERT. Postulates number 2 is saying a terminated line can be produced indefinitely. The line is here. Here it is A and here it is B. It can be produced in the either direction indefinitely. Note that what we call a line segment nowadays is what Euclid called a terminated line. So, according to the present day terms, the second postulate says that a line segment can be extended on either side of to form a line. Postulate number 3, a circle can be drawn with any center and any radius. Postulate number 4, all right angles are equal to one another. Postulate number 5, if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. For example, the line PQ in the figure 5.6 falls on a line AB and CD such that the sum of the interior angles interior angles 1 and 2 is less than 180 on the left side of the PQ. Therefore, the line AB and CD will eventually intersect on the left side of PQ. A brief look at the 5 postulates brings to your notice that the postulate 5 is far more complex than the other postulates. On the other hand, postulates 1 through 4 so simple and obvious that these are taken as self-evident truth. However, it is not possible to prove them. So these statements are accepted without any proof. See the appendix 1. Because of its complexity, the fifth postulates will be given more attention in the next section. Nowadays, postulates and the axioms are termed that are used interchangeably and in the same sense. Postulates is actually a verb. When we say let us postulate, we mean let us make some statement based on the observed phenomenon in the universe. It is truth validity is checked afterwards. If it is time, then it is accepted as a postulate. A system of action is called consistent. See the appendix 1. If it is impossible to deduce from these axioms a statement that contradicts any axioms of previously proved statement, so when any system of axiom is given, it needs to be ensured that the system is consistent. After Euclid stated these postulates and the axiom, he used them to prove other results. Then using these results, he proved some more results by applying deductive reasoning. The statements that were proved are called the proposition or theorems. Euclid deducted 465 propositions in a logical chain using his axioms, postulates, definitions, and theorems proved earlier in the chain. In the next few chapters on geometry, we will be using these axioms to prove some theorems. Now let us see the following examples how Euclid used his axioms and postulates for proving some of the results. Example number 1. If A, B and C are 3 points on a line and B lies between A and C, then prove that AB plus BC is equal to AC. Here A and B is a line and a point in between AB, C is there. Okay, here it is AC is the line and in between the B is there. Then we have to prove AB plus BC is equal to AC. Solution. In the figures given below, AC consists coincide with AB plus BC. Also, Euclid's axiom number 4 says that things which is coincide with one another are equal to one another. So it can be deducted that AB plus BC is equal to AC. Note that in this solution, it has been assumed that there is a unique line passing through 2 points. Now here 2 points A is there and C is there. So between of here from 2 points one line is passing, that is named AC. And here that point exists on the B. So AB also lies on the same line and BC also lies on the same line. So AC coincides with the AB plus BC. So AB plus BC equal to AC. Example number 2. We have used here the axiom number 4 to prove this postulate for this example. All right angles are equal to the another. So axiom number 4 is saying things which coincide with one another are equal to one another. Example number 2. Prove that an equilateral triangle can be constructed on any given line segment. Prove that an equilateral triangle can be considered on any given line segment. Solution. In the statement above, the line segment of any length is given, say AB. Here you need to do some construction using Euclid's postulate number 3. You can draw a circle with a point A as a center and AB as a radius. See the figure 5.2, 5.82. Similarly, draw another circle with the point B as a center and B as a radius. The two circles meet at the point C. Now draw a line segment AC and BC to form a triangle ABC. See the figure 5.83. So you have to prove that the triangle is equilateral, that is AB is equal to AC is equal to BC. Now AB is equal to AC since they are all the radius of the same circle. Similarly, AB is equal to BC, radius of the same circle. From these two facts, that Euclid's axiom that things which are equal to the same thing are equal to one another. So you can conclude that AB is equal to BC is equal to AC. So triangle ABC is an equilateral triangle. Note that here Euclid has assumed without mentioning anywhere that the two circles drawn with the centers AB, A and B will meet each other at point. Now we will prove the theorem which is frequently used in the different results. So that theorem is 5.1.